My name is Sarah May, and I am a Ruby and JavaScript developer at Pivotal Labs. And this is Backbone.js, Basics and Beyond. Before we get started on the actual presentation, I wanted to give you a little bit of an idea of why I'm up here. I've been doing Ruby since 2006, and for the first 4 years that I did Ruby, I managed to write web applications without ever really writing any JavaScript. And then 2 years ago, I joined Pivotal, and they want everyone to do everything. And so I started doing a lot of JavaScript. In the last year or so, I would say that my work has gone from 80% Ruby, 20% JavaScript to exactly the opposite, about 80% JavaScript and 20% Ruby. And I think that reflects a shift in where web applications in general are going, less on the server side, more on the client side. So I've used Backbone in a lot of different projects. Pivotal is a consulting company. My average project is about 3 months. So I've seen, I think, 8 different Backbone projects at this point. And the only project I've had in the last year and a half that didn't use Backbone used Ember.js. So I've looked at a lot of Backbone code. I've looked at a lot of horrible Backbone code. I'm going to show you something that's hopefully not quite so horrible. I'd like to get a sense of who I'm talking to, especially because this is a new conference. I had really no idea who's going to show up. So how many people have been on a project that used Backbone? Okay. How many people do mostly server-side development? That can include JavaScript. How many people do mostly client-side JavaScript and CSS and HTML? Wow, we've got a really interesting, diverse set of people here. Okay, that'll be interesting. Let's see if my clicker works. Yay. Okay. So I want to be really explicit about what level I'm targeting this at. Excuse me. First assumption is that you've done some JavaScript. You have some idea of basic JavaScript syntax. You may not have looked at Backbone specifically, but you basically know what the language is. I assume that you've done some JavaScript in the context of a web application. So you're familiar with the DOM and HTML and CSS and the interactions between the DOM and JavaScript. My code examples are in JavaScript that runs the browser, obviously. And I do use some jQuery in the examples, but if you're not a jQuery person, it should be fairly easy to follow along anyway. Third, I am explicitly not assuming that you are a server-side developer, nor am I assuming that you have access to the server that you are developing your Backbone app against. That seemed wise given and I think that is probably a good idea. And finally, I don't assume that you've ever looked at a JavaScript framework. Otherwise, you probably wouldn't be here. So here's our agenda. Oh, there we go. Okay, so I split all this out before I realized that O'Reilly actually has a break built into this. So I rejiggered the times a little bit, but we're going to we have a half-hour break, which is O'Reilly mandated between 3:15 and 3:45, and there will be coffee outside for that one. But I've decided to also take 2 5-minute breaks in the middle of the other sections, just because this is kind of dense. And I think most people, at least in my teaching experience, have trouble focusing on it for an hour and a half. So in the first part of the workshop, we're going to look at the basic building blocks of Backbone, and we're going to build a little app that doesn't do very much, but demonstrates all of the basic pieces of a Backbone application. We'll start off with what it is, why you might want to use it, motivations for the development of Backbone and things like that. Then we'll move into models and views. Then after the first break, we'll do templates, events, and then bootstrapping your application. And then the second half, I'm going to talk about a few different things that may seem a little random, but bear with me. We're going to talk about testing, how you test Backbone code. We're going to talk about real-world patterns for code organization, and that would be the highly opinionated part of this workshop. And then we're going to, in the last session, we're going to talk about other frameworks, how Backbone relates, where it lives in that ecosystem, and then get some questions. And I'm hoping to have some time at the end for questions, but if we don't have any time left over, I'm happy to talk one-on-one. So you are here. So let's start with a little bit of background on why you might need something like Backbone and what it is. So Backbone thinks of itself as being lightweight. What that means is it distinguishes it from something like Ruby on Rails, which is very opinionated. It has ideas about where the right and the wrong place is to put your code. Backbone does not have any of those ideas. It doesn't care where you put your code. It doesn't care where stuff goes. It doesn't care what stuff is mixed together. And I think as a result, Backbone code on different projects looks very different. So you can go from one Backbone project to another and have absolutely no idea what's going on in the second one. And I think that's interesting. I think it's interesting that you get such different results from different development teams using it. So you should probably keep in mind that anytime I show you how to do something, there are probably 2 or 3 other ways to do it that are common. A lot of this is what I've found to be the best set of things to do when you're working with a web application. That doesn't mean one size fits all. Of course, I'm right, but that's okay. So for me, one of the least obvious parts about something like Backbone, and this is me coming from a server-side development perspective originally, one of the least obvious parts is why do you need something like Backbone? So let's look at that for a moment. So what is it? It's lightweight. It is not MVC. There are a lot of acronyms and things that describe the different patterns for how people break up their code. But all of these frameworks, including Backbone, I think of essentially as a set of cubby holes where you can put different pieces of things. You get cubbies with different names. Each cubby you can put different pieces of code. And in theory, it helps you keep your code organized. Unfortunately, some of the cubbies in Backbone have the same names as in server-side MVC framework, which is very confusing. So in Backbone.js, you have models, templates, and views. So first of all, there's no C. They have no controllers, so there's no C in their MVC. And instead, it has models, templates, and views. Now, a server-side MVC has models, views, and controllers. So let's draw some lines in a moment. And I think before we do that, it's useful to back up and ask the question, why do we want to do this at all? Right? Why do we want to marry these 2 frameworks and make them work together? And why do you need a framework to organize your JavaScript when you're writing a server-side web application? The basic idea is better organization. But I want to unpack that a little bit because it's easy to say that and talk about how we got to the point where we need a framework to sort this all out. So what's wrong with plain old JavaScript? And to do that, I want to tell you a story about the evolution of JavaScript and server-side code. And I think I've talked to a lot of developers about this, and it seems like a lot of server-side developers, no matter if they're coming from Java or .NET or PHP, go through these same phases of their relationship with JavaScript. So phase 1 is the no JavaScript phase. This is the phase in which you either don't do any JavaScript at all, or if you do something like Rails that gives you JavaScript magic helpers, you just use the magic helpers. And when I came to Rails in 2006, coming from J2EE, the Rails JavaScript helpers were magical. They were amazing. I didn't have to write JavaScript. So I could do something like this, and it would create a form in my HTML with this magic little data remote true, and the Rails JavaScript would just swoop in and figure out that this was supposed to be AJAX submitted and do the whole thing for me. It was pretty magic. You can also do things like this, where you do this in your Ruby and you get this whole huge form that when you click it, it goes to the URL you specify and updates the div that you specify. So what it's going to do is when you click the link, it's going to go to the add to cart URL, and then it's going to update the div called cart when it comes back. So it does all of this sort of magically without you having to figure out what it does. And this kind of thing is certainly fine for simple interactions. And in 2006, that's kind of where we were anyway. For a lot of apps, this kind of stuff is fine. For me, I tend to think of these things, though, as sort of like the JavaScript equivalent of scaffolding. Has anyone here done Rails development knows what scaffolding is? The basic idea is you can generate a bunch of code that will, around a resource, so like a book or a comment or a post, and it will generate a controller and views and all this stuff, and it's what David Hansen used in his screencast, whenever it was, the famous screencast, build a blog in 5 seconds. So it's great for demos, it's great for simple stuff, but it's not something you really want to use in a real application. And as an industry now, we're kind of at the point where we need to make JavaScript a first-class citizen in all of our web applications, no matter what the other languages are that we're using with them. And we're at Fluent, so I probably don't need to convince you that we're at that point. Some people do need convincing sometimes. But one interesting question is, why are we at that point at all? And basically, it was just the Web 2.0 bit, right? So besides dropping vowels out of company names, what Web 2.0 really did was it was the product people requesting more interactivity than the kind of simple JavaScript helper kind of thing can give you, right? So what if you want to do a request and then update 2 different divs when it comes back? And you can make the helpers do that kind of thing, but at that point, it's usually easier to just go and start using jQuery directly, which brings us to phase 2. The jQuery explosion. This is what happens when you convert the magic helpers into actual JavaScript. And if you're using, a server-side framework that doesn't have these helpers, this is usually where you start. This is the beginning phase. It's called the jQuery explosion because you start getting stuff like this at the top of all of your HTML pages. And what we're doing here is that we are calling a jQuery plugin for auto-completing the username field, which usually your code those start multiplying, right, as you find a plugin that does this, and a plugin that does that, and a plugin that does the other thing. And then under that, we're doing some pretty basic AJAX stuff where we're saying when this form is submitted, do this AJAX, and when it comes back, update a couple of things. And this behavior is a pretty decent amount of code, and it's really only for one form. And there's never just one form on a page, generally, right, these days. And so you can imagine this gets pretty out of control pretty quickly. And the views, under standard server-side MVC, your views are supposed to be dumb. They're not supposed to have anything in them. And so if you're going through this process and you're putting a bunch of JavaScript at the top of every page, you're sort of defeating the purpose of that type of V. And it starts looking messy. And I'm not, a lot of web applications sort of stop at this phase, right? What they do is they do this, they realize it's messy, and maybe they pull it out into a file and just include it at the top of the page, but it's essentially the same idea. And the main drawback is not actually the aesthetics of it, it's the fact that it's really hard to test. So the only way to test JavaScript that's thrown into the top of the page is Selenium testing or other kinds of acceptance testing. And those are really slow. And what that means is that as the interactivity quotient of your app goes up, your tests get slower. And that means the tests don't get run, and that's a bad thing. And so the other option, of course, is not to test the JavaScript, I suppose, which I know a lot of people opt for. So when we got to this point, and a lot of people looked at this problem, and they kind of all came up with a very similar answer in some respects, which is page objects. And in this pattern, we take all that JavaScript that was just thrown into the top of the page, and we separate it into sort of unit testable functions that are on a JavaScript object that's included into the page. So let's look at an example. So here's a page object that contains the JavaScript that we had previously just kind of thrown into the top of the page. And it's about the same amount of code and is doing the same thing. But the difference here is that we can actually unit test these individual functions instead of having to test the entire thing by a Selenium test. So we can write unit tests for doCreate to make sure that it's sending off the right things to the AJAX and doing the right things when it comes back. And then we just need a Selenium happy path test to make sure that nothing's smoking, right? So it sounds like kind of a small thing sometimes, but the ability to unit test your JavaScript is pretty huge. Selenium tests are really slow, and we have one application at Pivotal. It's a large client-side app written in Backbone. It has, I think, 3,000 JavaScript unit tests that run in a minute and a half. And the equivalent, if we wanted to integration test all that stuff, would be about 4 hours. So it saves you a lot of time. And it also means that tests get run more often, right? If someone's checking something in, maybe even a server-side developer, they might run the JavaScript test if they only took 15 seconds, rather than, but they probably wouldn't run the Selenium suite that takes an hour. So the next sort of thing that happens usually with page objects is you've got an object here that represents your page, and then you start componentizing the pieces that are in it so that you can reuse them across pages. So your initialize basically becomes a box for other initializes to be called, for the most part. So it does get nicer looking. It goes from, in your view, goes from this to that, which is nice. And this pattern can actually take you pretty far. And there are a lot of web applications for which this is definitely sufficient. At this point, you can unit test your JavaScript, you can organize it into pages, you can organize it into subcomponents and test those individually, reuse them across different pages. Where it starts to break down is when your product people decide that they want to go for a sort of single-page app feeling to the application. Basically, when you start thinking about doing client-side rendering, you've outgrown page objects. And we'll talk a little bit more in a moment about what exactly that means. But so page classes are awesome and probably sufficient to organize your JavaScript if you're still doing server-side rendering. But most people don't want to do that anymore. Here's Twitter, which I'm sure none of you use. Twitter and or Gmail are usually considered the canonical single-page apps, right? So you click on a link, it opens inline, and then if you click on it again, it opens up in a modal. So you never actually really leave the page. From the user's perspective, there's no page refresh. And apparently, this is what kids like these days. So the product people start asking for stuff like this. And in practical sort of development terms, what that means is they're asking for more interactivity than you can reasonably do with like redirects and AJAX calls. Because when you're clicking a link, right, it's this, when you click a link on Twitter, it actually renders a decent chunk of markup, right, on the client side that it didn't have there before. So you start thinking about, of course, doing client-side rendering with something like Mustache. And once you're doing this, you start realizing that you need to attach templates to individual page classes, right? You really want a template to belong to a particular page class. But then you start needing to know when you're supposed to render and re-render all of the subcomponents, and under what circumstances do you render subcomponents, or do you just render the whole thing over again, or do you, all of that kind of stuff. And you probably start needing to maintain some state in some sort of object. So what you start thinking about is like, wouldn't it be nice if I had an organized way to associate a template with a component and a way to make all of my events that change the state do something, be a little bit more organized. Because you start doing a lot of events. You're probably generating a lot of events at this point, right? You're generating events inside the subcomponents of your page class. And inevitably what will happen is that you have two subcomponents that are siblings of each other, and one subcomponent does something that the other subcomponent needs to know about. So how do you pass that message to them, since they're not, one is not the parent of the other, right? How do you give that object an event, or otherwise send it a message that tells it, do something, re-render, get more data? So this is particularly messy because DOM events only bubble up, right? So if you want an event to be caught, you have to be in the direct ancestry of the object that generated the event, which often is not the case. And what this means then is that the page class starts having to know about which subcomponents want which events, and it starts having to be the mediator where it gets events from its subcomponents, then looks and sees which other subcomponents want to hear about them, and then push them down. It gets messy really quickly. And usually around the same time, in my experience, you start wishing for some way to mirror your data between the client side and the server side. You start thinking, wow, wouldn't it be nice if I didn't have to refetch every single message every time, and I could just maybe store them in JavaScript and make changes to them and have them be persisted back to the server. Because it starts feeling like you're writing the same RESTful AJAX methods over and over again, right? You're writing the same, you put to do an update, you post to do a create, and you're writing it for basically the same functions for different resources. So what drives people away from the page class model is essentially more interactivity, and what that means is more events and more state. So this drives us into the arms of frameworks. Now, there's a lot of frameworks out there. If you can just look at the schedule and see that. And they all solve these problems in different ways. So there's Backbone, and then there's others. I made this slide like a week ago, so there's a bunch of new ones probably since then. All right, going too far. All right. So we're going to talk a little bit towards the end of the workshop about the differences between Backbone and some of these other frameworks, because I think that it's useful for you to see how Backbone works first before I tell you about what makes it different from the other ones. At this point, I think the important thing to keep in mind is that all of these frameworks are addressing a similar class of problems. They're all trying to make it easier for you to write a large JavaScript application. Now, there are different types of large JavaScript applications, right? Not all of them are client-side web applications. So these frameworks tend to target different types of applications, or they target the problems in slightly different ways, but they're all essentially trying to help you write large JavaScript applications and keep everything organized. So now we've got an idea of what problems the frameworks are trying to solve. Let's have a look at what Backbone actually gives you. And the first thing it gives you is semi-automatic model mirroring, and we'll come back to what that means in a little bit. And that's handled in what Backbone calls models and collections. Second, it gives you views that handle DOM events, which can also optionally be attached to a template that renders markup. So coming back to this model, template, view, controller, et cetera, comparison chart, conceptually, models are about the same on both sides. They're meant to encapsulate a business object of some kind, like a tweet, or user, or comment. To be a little more technical about it, a Backbone model usually mirrors a resource, an API resource. And the set of Backbone models thus usually tends to look like your set of RESTful API endpoints. So for example, your RESTful API endpoints may or may not correspond one-to-one with the models on the server. So let's look at a social network, because everyone loves social networks, and I didn't want to do another to-do app. And a social network on the server has these three models: a message, a user, and a friendship. Friendship is a join table between users. And this is actually the part of the app that we're going to build today. Messages are pretty straightforward, right? You can expose them as a messages resource. And that corresponds more or less directly to your server-side model for message, and it kind of makes sense to make a Backbone model called message that represents that resource. So it's not so straightforward when you come to users and friendships. So a friendship, you may not want to expose as a resource on its own. You may want to expose a resource called friends, maybe, which is a user with a bunch of extra information about their relationship. And then maybe you want a normal /users, which exposes users, maybe for autocomplete. And then you probably also want a singleton resource for the current user. And it makes more sense, generally speaking, to model these endpoints in Backbone than it does to do a one-to-one correspondence between stuff you have on the server and stuff you have in the browser. So views on the server side generally tend to be sort of logicless, more or less, templates. And that's what Backbone calls them. Backbone calls those templates. So where it gets interesting is with this third one. A view in Backbone is not a template. And this took me a long time to figure out, and this is because I was probably coming from a server-side MVC framework standpoint. A view in Backbone is a lot more like an iOS view controller. Anyone done iOS development or Cocoa development? Few people. Well, in those frameworks, they have the idea of a view controller, which controls a little piece of the UI. And basically, that's what this does. So a view is a Backbone object that controls a certain part of the DOM, a certain part of your interface, handles events, handles rendering. And so it's kind of, if you want to think about it in terms of correspondence to the server-side MVC, it's sort of the C part, right? It's a lot of it has a template, it may have a template, but it's basically the part that receives events from the user interface and then figures out what to do with them. Let's see. So that's the end of our intro, so I thought we should take a deep breath. Okay, that was mostly for me. So let's look at how we actually build a Backbone application. So there's three basic parts of building a Backbone app. First, you need to get some data from the server. Then you need to render some HTML elements. And then you need to handle some events. And of course, then you need to bootstrap the app somehow. And I spent a long time thinking about how I wanted to do the code for this workshop. I ended up writing a little, let's talk first about the server. I ended up writing a little Rails application, which probably most of you may or may not be able to run, that does the API. And I have it up on a Heroku instance, which all of you should not hit at once, probably. But you can clone that. That has the server that we'll be running against. But with the conference Wi-Fi, I kind of doubt anyone's going to be able to do it anyway. So here's our mock-up for the application we're going to build. So there's a lot here on this mock-up, obviously. There's a lot of features. So we're just going to focus on the part that's like getting people's updates into the page, right? Just that part. We're not going to worry about following or friending or logging in or the sidebar. We're just going to do that. That's going to take us a while. So here's the basic structure of our Magic API. And I call it Magic because we're just going to kind of assume it exists. It responds to our requests. So we're building a client-side application for creating, or mostly actually at this point for viewing status messages. So we're going to assume that we can hit /messages.json and get a JSON representation of the messages. And so if you've got two messages in the system and you hit just plain old messages, then you get this ugly HTML page. And if you hit messages.json, you get sort of the JSON representation. It's the same two messages, but with all of their metadata and extra stuff in JSON format. So that's what we have to consume. And we're going to take that and build the view that shows you the different messages. So I want to pause for a moment here and talk briefly about REST, which I've been saying a lot. And this is really simplified. I originally put REST 101 on this form, or on this slide, and then I realized it's not even 101. This is like the quick and dirty version. So REST is just a way to organize your API endpoints around the idea of resources. So a resource is something like a message or user or a comment or a post. And when you implement a RESTful API for a message, for example, it looks something like this. This is not a complete implementation of REST, but the way to read this is that there's 7 actions you can take on messages, right? And these are divided into actions you can take on an individual message, which are those, right? They all have an ID in the URL. And actions you can take that don't involve a specific individual message, right? So in REST, each one of these 7 actions is associated with a different location on the web. And you'll notice that some of them have the same URL, but if it has the same URL, then it uses a different HTTP verb, which is the first column. So you notice the last three, all have the same URL, but you use a different verb with your request, and the HTTP spec thinks of those as different locations. So the only reason you need to know this is because Backbone knows about REST. And you don't need to memorize this chart. The important thing to take away is that if I give you /messages, then you can figure out where all the rest of the endpoints are. Right? There's a standard format for how that works. So we have this JSON, right? We want to build that. So that's what we want to build. So let's look at some code finally. So let's look at some models. So if we wanted to make a model that represented a message, it would look something like this, relatively straightforward. The JavaScript is a JavaScript object that extends Backbone.model, and that's how Backbone does inheritance, right? So you can think of that as the base class if you're coming from a class-based inheritance background like I am. And anything you pass to that extend call will override the defaults, but for now we're actually happy with Backbone's defaults, so we're just going to pass in an empty object. So that's a model for an individual message. So for what we're doing, it really doesn't matter an individual message, right? We actually care about a collection of messages. And in Backbone, a collection is a separate thing. So let's make a messages collection, which, like the model, just extends Backbone.collection. But in this case, what we're doing is we're passing in a few different things that are overriding the Backbone defaults. The first thing we're passing in right there is we're telling it what model it is. So a collection has a particular type associated with it. So we're telling it, OK, you're a set of models. And then we are giving it a URL. And this is where the REST magic stuff comes in, right? We're giving it /messages, and from that, it will figure out how to get data for a list of messages, get data for an individual message, update an individual message. And because we've told it that its model is the message model, it then will tell its models how to update themselves if they change. So the next question people usually have is, how do we get a set of messages into this collection in the first place? So here's how we create a collection object. And in the first line, we're creating it. The second line, we are just fetching it from the server. And fetch is a Backbone thing, which will look at the URL that you've given it and figure out where it should go to get data. So in this case, it will go to /messages, which you remember we assigned because we assigned that when we were starting it. So to diagram it out explicitly, when you call fetch, what happens is it goes to our server using a get to /messages.json, and what it gets back is a JSON set is an array of objects. And it goes through and creates a model message, or a message model object for each one of the elements of the array that comes back. So that lets us avoid writing all of those AJAX calls that we would otherwise have to write. All 7 of them, basically, which is nice. It gives you, that lightens up the JavaScript considerably, just that. So that's pretty awesome. We have a collection of messages. But it turns out that just having that doesn't actually do us a whole lot of good because we have no view. We have no way to look at these messages. We could look at it in the JavaScript console, but we need a view. So let's see, you've done that part. Let's look at views. So we wrote a message model and a message collection. We're going to leave those aside for a moment and start looking at Backbone views. So if you remember from what was all of 5 minutes ago, when I was talking about views, views are actually sort of a view controller. So they're an object that controls a certain part of the DOM, handles events, does all that stuff. So a lot of the code in a Backbone application tends to be in the views. Tends to. So if you look at what we're trying to build, you can kind of see like this part could be a view, and if we wanted to get really fancy, like these parts could be subviews within that view. And we're just going to completely ignore the sidebar and everything else. Those could be individual views also. So we're going to start with a top-level view for that whole area in red. Deceptively simple. So just like our model and our collection, we're extending the basic Backbone view class, Backbone view object, and we are giving it one piece of data about what we're doing, and that is the class name of the DOM element that we want it to control. And Backbone is very flexible, so when you're creating a view, you can either give it an element that already exists on the page, or you can give it a class and tell it to, and it will create a div with that class on it. And you can also give it a tag name, so you can have it create, for example, an li instead of a div. So in this case, what we're doing, though, is we're telling it to create, that it will be in charge of a div that it needs to create with class messages container. So here's how we create an instance of that view. And when we do this, it creates a div element with the class, and it holds onto it, but does not insert it into the DOM. And that's on purpose. Backbone wants you to have control over when repaints happen in the browser. JavaScript is a very fast language as long as you don't touch the DOM at all, right? So especially in large applications, you'll end up with a lot of code that tries to make sure that you minimize the times that you touch the DOM and batch updates and things like that. And Backbone supports that kind of stuff. So our messages container element exists. It's boring. It's empty. We haven't given it any data. We haven't given this view anything to view yet. So let's combine this with what we did earlier. So earlier we made this, we made a messages collection. And we fetched the messages from the server. And now what we're going to do is we're going to create a messages view, and we're going to pass in that collection. Now this part should look familiar. This we did before. This is a bit newer. And collection is a magic parameter to a Backbone view. Typically, a Backbone view thinks about it, it can be associated with an individual model, or it can be associated with a collection. And so you can pass it, model as the parameter, like you could think of, if you're looking at a profile page, probably the model that you'd pass in would be the user whose profile you're looking at. So we're giving it a messages collection, so it's got a collection now. But it still doesn't actually render anything. So Backbone does not automatically render the data that you give it. And again, that's on purpose because it's lightweight. So you need to write a render method that does it for you. So that'll bring us to templates. And I'm almost exactly on time. That's amazing. I'm a little early. So we were scheduled to take a 5-minute break. And what I'd like to do is, I want to take the break because I think it's good to surface for a moment. And if you have questions about the stuff that we've done during the previous section, you can come up and ask me. And then we'll come back at 2:30, and we'll go on to the next thing, which is templates and events and starting the app.